Hello and welcome back to Chemical Tips by Mr. B. In today's video, we'll be having a look at tackling one of the trickiest questions I've seen on titrations based solely on Year 12 content. So let's have a look at seeing what makes this question so very difficult, and let's have a stab at it. So I'm going to start off by highlighting the key points the key bits of information in the question. So you're told that a student plans to determine the concentration of ethanoic acid in a bottle of vinegar. So that's pretty straightforward. That's the whole purpose of this titration. The student will carry out titration with barium hydroxide, and the methods outlined below. So we're starting off with 10 centimeters cubed of vinegar from the bottle. We're adding this with water to make a solution up to a total volume of 250 centimeters cubed. We're then going to titrate this diluted vinegar with 25 centimeters cubed of our barium hydroxide. You're told that the mean titer of the diluted vinegar is 25.45, and you've been provided with a balanced symbol equation for the reaction between ethanoic acid and barium hydroxide. Now, there's a lot of information there. I'm going to start off, and generally with titrations, I like to identify what's going on big picture by a quick sketch. So we've got an original bottle of vinegar. From this bottle of vinegar, we're taking 10 centimeters cubed, and we're making this weaker. We're diluting it by adding water until we've got a total of 250 centimeters cubed. So this is our diluted vinegar. Now we're going to take the diluted vinegar from the volumetric flask, and we're going to pop it into a burette, and we're going to titrate it with barium hydroxide. Awful diagrams, I know. We're not going to get marked on this, so it's fine. So we're told that in the burette, we had a mean titer of 25.45 centimeters cubed of diluted vinegar. That's this bit right there. So we've got 25.45 centimeters cubed of dilute vinegar, and we've titrated it with, I believe it's 25 centimeters cubed. Yep, 25 centimeters cubed of 0.0450 mol DM-3 barium hydroxide. And ultimately, we've been asked to work out what the concentration of ethanoic acid is in the original bottle of vinegar. So so we've now got an idea of what's actually going on, and certainly I have. This for me is a lot easier to understand than all of this. So let's have a look at tackling this question. We need to calculate the concentration of ethanoic acid in the original bottle of vinegar. To do this, I'm going to identify what I have, for which substance I have the most information. Now, I've been told I've got a volume for ethanoic acid. That's my mean titer of vinegar as 25.45 centimeters cubed. So I know that. I know the volume of that. For the barium hydroxide, I know both the volume, which is 25 centimeters cubed, and the concentration, which is 0.0450 moles per decimeter cubed of barium hydroxide. So I've got more information for the base, for barium hydroxide, than I do for the ethanoic acid. So if I've got the volume and I've got the concentration for barium hydroxide, what can I do with this? Well, I can work out the moles of barium hydroxide using moles is equal to VC. So pop that down. We know that barium hydroxide, we know that we can work out the moles using N equals to VC. So the volume of barium hydroxide is 25 times 10 to the minus 3 because we need to convert into decimeters cubed. So that's 25 times 10 to the minus 3 decimeters cubed of barium hydroxide multiplied by the concentration, which is 0.0450, and that gives us a value of watts. Let's see. So that's 25 times 10 to the minus 3 multiplied by 0.0450, and that gives us a value of 1.125 times 10 to the minus 3 mol. So I know the moles of barium hydroxide in my conical flask right here, right? Okay, how does that help us work out the concentration of ethanoic acid in the original vinegar? Well, I've been given the equation. I've just worked out the moles of barium hydroxide there. If I know the moles of barium hydroxide, I can work out the moles of ethanoic acid that this reacted with according to the balanced equation. We're told that there is a ratio of 2 to 1 of ethanoic acid, so that's CH3COOH to barium hydroxide. So if I know the moles of barium hydroxide as 1.125 times 10 to the minus 3, then it means that the moles of ethanoic acid will simply be 2 times that. So we're going to have 2 times 1.125 times 10 to the minus 3, and that's equal to 2.250 times 10 to the minus 3 mol, and that's the moles of the ethanoic acid, CH3COOH. But that we need to identify what volume is that in. Well, according to our diagram here, that's in a volume of 25.45 centimeters cubed of vinegar, of the diluted vinegar. That's in 25.45 cm cubed dill vinegar. Okay, we know that. How does this help us? Well, we know our original diluted vinegar solution started off with a volume of 250 centimeters cubed. So it's prudent to work out the number of moles of ethanoic acid in the original 250 centimeters cubed of the diluted vinegar. So how do you do that? Well, if we know that in 25.45 centimeters cubed of vinegar, we've got 2.25 times 10 to the minus 3, it means that we have to multiply that up to get the number of moles in 250 centimeters cubed. So let's have a look. 250 divided by 25.45. Let's see how many times it goes in. So 250 divided by 25.45. So that's 9.82. So what I'm going to do, I'm going to multiply 2.250 times 10 to the minus 3, which is the number of moles of ethanoic acid in 25.45 centimeters cubed, and I'm going to multiply it by this number 9.82 because I want to work out how many moles of ethanoic acid there are in the original diluted solution. So we're going to do 2.250 times 10 to the minus 3 multiplied by 9.82. So that gives us 2.25 times 10 to the minus 3, which is equal to 0.0221. 0.0221 mol. So that's the number of mol in 250 centimeters cubed of the dill vinegar. Dill vinegar. Okay, so we've now identified the number of moles in this bit over here, right? But we need to work out how many moles there are in the original solution. Well, if we consider this, we know or we've identified that there are 0.0221 mole in the diluted solution. And to have made this diluted solution, we started off with 10 centimeters with 10 centimeters cubed of ethanoic acid, and we must have added 240 centimeters cubed of water, right? So we're starting off with a solution of a volume 10 centimeters cubed to a solution of 250 centimeters cubed. So that's a 1 to 25 ratio. So we have diluted the original vinegar. So we've diluted this original vinegar by 25 times. So how are we going to work this out? Well, if we know the mold in this diluted solution is 0.0221, we can work out the concentration in this diluted solution. So we know that N is equal to VC. We know that C is equal to N over V. So if we literally just sub the data in, 221 divided by the volume, which is 250, this so we can get the concentration of the diluted solution, which, yes, it's not what we want as our final answer, but it's going to help us get there. So we're going to do 0.0221 divided by 250. I can't forget, I need to convert that to decimeters cubed. So that's 0.25. And we get a value of 0.0884 mole dm minus 3. So we know the mole, we know the concentration of the diluted solution, and we've as 0.0884. We know the dilution factor was 25 times, so we're simply going to multiply it. We're going to this concentration 0.0884 by 25. So multiply by, because it's a 25 factor dilution, so we need to get the original concentration back by multiplying by 25, which gives us a value of, so I'll just show that working out here, 0.0884. They really haven't given enough space here. But remember, in an exam paper, you can always ask for extra paper under exam conditions. So multiply by 25, so that gives us 2.21 mole dm minus 3. Notice I'm giving my answer to 3 sig figs, simply because the data I've been provided with, the lowest number of sig figs is from the ethanoic, from the vinegar itself, the volume, which is 10.0. Okay, so we've identified the final answer for this as 2.21 times 10 to the minus 2.21 moles per decimeter cubed. That is the concentration of ethanoic acid in the original bottle of vinegar. Now, part 2 suggests one assumption that the student has made that might mean that their calculated concentration of ethanoic acid in vinegar is invalid. An assumption. The calculated concentration, so what we've just calculated, is invalid. Predict with a reason how the experimental result would result from the actual concentration in ethanoic acid if the assumption was incorrect. Okay, that's quite wordy. One assumption that might mean that the calculated concentration of ethanoic acid is invalid. Well, in this case, we're assuming, aren't we? The assumption must surely be that we're assuming that the vinegar contains only ethanoic acid. Yes, it is a key ingredient, it is a key component, but we're not told anything else about it. So the assumption must be, so we are assuming, let's just move that out of the way. Assuming vinegar only contains ethanoic acid, CH3COOH. There could be other acids, there could be other components that are going to affect it. So predict with a reason how this will cause the experimental concentration to differ from the actual concentration. Okay, so if we've assumed incorrectly that vinegar is made up of only one acid, ethanoic acid, and supposing that it contains more than one acid, then that must mean that if we've got more acid, we're going to have more barium hydroxide reacting with this. If we've got more barium hydroxide reacting with this, then we've got more moles of acid to begin with, whatever the mixture of the acid is, ethanoic acid and other and anything else. So if we've got more moles of acid, then that must mean the concentration of the acid is also greater. So therefore, the concentration of the experimental result would be greater than the actual result that we've calculated earlier. So the concentration of the experimental results would be greater. That's all there is to it. Tricky question. Very, very tricky question indeed. But it's really important that when it comes to these sorts of questions, you always take your time, lay out what you know in a logical manner. And again, I personally really benefit from using this approach. Okay, I hope that was useful. Until next time. Bye.